Welcome. This is a very early iteration on a presentation to introduce Ikigai. Ikigai is a nights and weekends personal project, so all thoughts here are my own. Blame me, not anyone else. Ikigai, the word, was given to me by a friend. It's a Japanese word. It means the intersection of what you love, what you're good at, what the world needs, and what you can be paid for. I thought that it fit perfectly for this project, so I got this name. And just in general, I think I've been pretty lucky in my life to be able to mostly be working on projects that I found interesting that actually also mattered. Hopefully that gets to continue. What is Ikigai? Okay, so the easiest place to start is to say it's just another coding agent, like Claude Code, Gemini CLI, Codex CLI, OpenCode, or any of the dozens of others. There is a true Cambrian explosion going on in this space right now. If I took the time and went through all my notes, I could probably find 30 or 40 projects with an agent in development. I do think that Ikigai has some unique aspects that will make it different. And that will be what I am, going to be focusing in on through the rest of the presentation here. It's also important to know that Ikigai is a kind of a multifaceted experiment for me. It's a learning experiment to understand how agents work, but it's also an experiment to see just how far I can take agentic software development. What better space to do it in than developing a coding agent? I get to dissect what's going on the inside to help myself understand what the limitations are and figure out just how far I can take them. Okay. At this point, I think most people using agentic tools have come to understand that it's more than just prompting. It is context engineering. And recently, Google coined a term called context-driven development, which I really, really like. I also think that recently, a lot of people have started to wake up to the power of sub-agents. If you have a parent agent that spins off a sub-agent and does a whole bunch of work, fills up its context while doing that work, and then just reports the answer back to the orchestrating parent agent, who has plenty of context left now to run additional sub-agents, right? It's a very, very powerful tool, but again, it's very tightly tied to, why do it? It's very tightly tied to context management. I think a little bit more overlooked is tools are critical in context management too. The early iterations of MCP and even the agent-supplied tools tend to waste memory if you're not using them, waste context if you're not using them. If you're building a sub-agent that's going to do nothing but classify a document, and it needs nothing but the file read tool, there is absolutely no reason for any of the MCP or other tools that you have in context. And so what Ikigai is all about is giving the end user all the tools to surgically control context. And hopefully that'll show through as we're working here. Okay, so here is, let me get back. Here is some of the stuff that we will be covering. I need to make sure that we actually have Ikigai running so we can take a look at this. Seems like a lot, but some of that will go pretty quick. So one of the first things, and this probably doesn't even deserve to be in the presentation, is just a little comment I want to make. Ikigai is a terminal-based agent, and it is intended to be a first-class citizen in that world. It's going to have full UTF support. It's going to support, the more modern terminal emulators, things like the Kitty protocol, and, full international keyboard support. And I'm just calling out here that just yesterday I learned about something that I missed, which is these the zero width joiners in UTF. And if nobody's ever been aware of these. I'm just going to share them here for a second. So Ikigai's user interface is, pretty terse. It's in a pre-tech demo stage right now, and it's gotten no UX love. So the purpose of Ikigai at this point is just to be able to run and demonstrate the foundational pieces that we're building. Nonetheless, one of those foundational pieces, of course, is a multi-line REPL editor. A lot of people may not know this, but emojis, you figure this out when you go to write one of these. Emojis are 2 characters wide, or 2 cells wide. So notice if I back arrow, we're twice as wide, right? So that, of course, causes some problems when you're trying to navigate around in a multi-line editor. That all works. The thing that doesn't work right now is these zero width joiners. So this little emoji down here, you can see is a family of 4 people, and you can see the cursor ended up in the wrong place when I pasted it. And the reason being is it's actually 4 visible glyphs that are separated by 3 zero width joiners, and they should be rendered as a single cell. But they're not. That's a bug I have to fix. But you can kind of see this crazy behavior now. If I back arrow through these, so the first back arrow, you see the emoji actually changed to a family of 3 because I just deleted the daughter off of the end. Now if I delete a joiner and I delete another one, I just deleted the second child and we only have the 2 parents. Apparently there's not an emoji, family emoji for 2. So now when I delete a joiner and another emoji, that one disappeared, and then a joiner and the parent, the father, disappears. Crazy stuff. All things that I'm not sure why, but I'm sharing a bug. And really just to say that Ikigai is going to be a first-class citizen. I take these things seriously. It will have perfect support for all of these things in the future. And it is not quite there. Okay, moving on. Multiple providers. Okay, if you're using a tool from a singular provider like Claude Code, it makes sense that it only supports their agents, or their models, I mean, but obviously any other tool should support many models. And currently, Ikigai supports Anthropic, OpenAPI, and Google, and eventually it will expand beyond those. But the way that it works is, of course, that you can just pick a model. So let me do the easiest one to type, which is GPT-5, and I'm going to say none. And so what you just seen there was me selecting GPT-5 and specifying that I wanted no thinking. Not only do I support the multiple providers here, but we try to support all the features of every provider. So Ikigai itself is a large superset of all available features, and then where necessary, we will do the translations or even polyfill the functionalities so that it works. Now, just to demonstrate what is 1 + 1, just to demonstrate that this thing actually is talking to agents. It just gave me an answer, and we can switch to let's do Claude Sonnet 4.5, and we'll do high thinking. They all have slightly different representations of each of these providers has a slightly different representation of how they do thinking budgets. Here with the Anthropic API, it's always some number of tokens. Google actually changes from the 2.5 to the 3.0 Gemini. It changes how it does it. So if I were to do a model and do Gemini to 2.5.flash, it kept the high thinking, and you can see it actually has a particular budget. But if I do model Gemini 3.0 Pro, and let's go high, you can see that it just says high level. And the reason for this is that Gemini actually switched from having a thinking budget to just a high-low setting. And so, what I'm doing, what I've chosen to do so far is I have a none, medium, low, or none, low, medium, high budget. And what that does is none is clearly 0, and low is 1/3 of the budget. Medium is mapped to 2/3 of the budget, and high is mapped to 3/3 of the budget. Whatever budget is available. My intention is in the future to also support the native description. So you could set it with these keywords, or in the future, you'd be able to specify a token budget if the underlying agent supported a token. But for the time being, it is just the keywords. Okay, so multiple providers, all fully supported. Permanent message history. This is another big kind of anchoring point for. This is one of the things that does differentiate Ikigai. Ikigai stores all events into a database, and so let me just say, make sure we're in the right place there, and I'm clicked on the right window. What is 1 + 1? Let's just get something that's in the message history. Okay, so we have something in the message history. If we quit from Ikigai and we restart, you see that nothing changed. We're in exactly the same place. The conversation, is what it is. To the point of what was the answer? Let's do it a little different. What is the result? Right. So the way that this works is every single thing that I do ends up as event history in the database, and every single response that we get from the agents from the model ends up as event history in the database. When I quit and then restart, what happens is Ikigai scrolls back, finds the last clear of the context, and then replays it from the database into memory. So then when I go and ask the next question, the message history is all there, and it still gets delivered to the LLM. And it seems like everything is permanent and forever. Now, I don't think that Claude Code had these things when it very first originated, but it does have some command line functions now, and they do kind of do this work. But with Claude Code, it's writing its history in files on the file system, and so it becomes a lot harder to manage. And it certainly isn't going to have the features that I'm going to be able to do with it in the future. I'm going to be able to have background agents that are dealing with the database and stuff that you just wouldn't pull off easily having them written to files on disk. And so this will be a big differentiator down the road. Okay, so hierarchical agents. Let's clear here. And let me see if I left any running. Okay, so you can actually see that this is the root agent, and you can actually see its identity here in the separator. So that is the agent that we currently are. And this one, was from previous work I had left it running. I can kill that agent. So that way I can kind of demonstrate this from the top. So I'm going to clear again. I'm going to get the agents list, and you'll see that now we only have the one agent. Okay. To create a new agent, actually, before I do that, I'm going to say, what is 41 plus 1? So I'm going to put a little something in context so we got something to look at, and then I'm going to say fork. And what fork does is you'll notice that this was the parent root agent, and what happened, there was not much of a visual indicator there. The user experience has not been my focus yet, right? So that will happen at some point. But what happened is a new subagent got created. So if I were to ask what the agents are now, you can see the agent, when we forked, we became this new child of the original root. When we did that, it was given the exact same history, and that's largely why there was like no user experience to tell you anything happened other than the little change down here. Is because the new agent had the exact same history from the previous. It literally forks, and they're both identical at that point. Now, what's different, of course, is this subagent can ask questions, and it can have a history of its own that, of course, is going to differentiate. So now we have this what is 3 plus 3 question in the subagent, but if I pop back up to the parent agent, you can see it only has the history up to the point where it forked. There are some quirks that are in the code I'm going to show here. So if I exit and then reload, you can see you didn't actually see this before, but we're back in the parent, we're back in the root. And here you can see the event replay, and it said, hey, at this point, I forked, this child. That message should have been in the previous stuff too. It's just missing from one of the render loops. And more importantly, if you jump over, all subagents replayed their histories correctly. So the parent root agent only ever got to the point where, what is 41 plus 1? And then a fork happened, right? But if we go look at the child, we can see that we also then had the eventual history where, so we have the old history up here, right? But then we have the eventual new stuff where we asked, what is 3 plus 3? So it has its own history. Now, these are completely disconnected. So if at this point I clear the child's history and I pop back up to the parent, and then back down to the child, it has a zeroed out context. Once forked, they're separate. But what they do know is they always have a reference to their children and to their parent if they need it. Okay, so subagents exist in Claude. They don't exist in a lot of other tools, although they're starting to pop up in them. And in Claude, though, you don't have like any kind of first-class access to that subagent. You can see an agent in a to-do list, what it's currently doing, but that's it. And if it has subagents, you see nothing. And so the user experience inside of Claude is you really only interact with the root agent, and if there are others, you never can interact with them. And that will be different for Ikigai. You are going to be able to, the idea is that you will have long-running agents that are semi-permanent, maybe permanent, and you will be able to navigate down to them. There will be better navigation tools than I have today. Right now, it's just a control up and down and left, right. But, all of that will develop in time. Okay, so I am going to kind of clear this and take a look. And so we still have both of those agents. So both of those agents are running. One of the next things that we have is inter-agent communication. And so this is a little bit different than how it's very similar. It's a little bit different than how Claude Code does. So like it has a to-do list, and then it has a tool that it can get the completion state from its subagents. But with Ikigai, you'll be able to duplicate that exact experience but you also they are disconnected a little. So if I pop down into the child agent and I say, actually, I need the list of agents because I'm going to send this agent a message. So if I say send this agent, right? So I've now sent mail to that other agent, the root agent, in fact, the one that spawned that agent. And if I am in this agent and I check mail, you can see, well, I didn't clear the mail out from before, but the ZK message, this is it. The result is 42. You can see I've done similar things in the past, but nonetheless, we can check and we can see that there's mail, and we can also read the mail. So they're in most recent order, right? So if I read mail 1, if I read mail 1, the result is 42. So that is the exact message that we had put into the message. This works. The way that the message gets pulled into the context is that there's a little bit of future work here because this isn't all put together, is it's going to fake a tool call. So normally the LLM asks to use a tool, and we do it on its behalf, and then we give it a tool result. And then that can appear in the history. And what we're going to do to bring in, so let's say the user is typing, to read the mail. What we're actually going to show in the history to make the LLM understand that it just read the mail is it's going to see a tool call and the result. The thing is it's never going to have asked for that tool, but they're stateless and then they don't know that. So, it'll work out just fine. And of course, we can delete mail 1, and the mail gets deleted, right? So it's pretty straightforward. So, What is next? Database file store. Okay, so from here on out, there really isn't matching completed work. It's just a discussion about what will come. Database file store. Ikigai is intended to have agents that are long running. It's going to have a parent agent that is probably overseeing like all of my projects. I'll have sub agents that are sitting out in actual project repositories. One of the things you realize when you're thinking about that structure is that the current pattern in most tools is to put all of the context into markdown files inside of the project repo. But clearly I'm going to need to be able to share some of those files, skills, whatever it might be, between my agents. And they're scattered around in multiple repos. So the obvious solution is to create database files that are accessible to all of them, and then make all of the file read, write, editing tools be able to understand a URI that can reference a file in the database. So you guys probably familiar. Sometimes you'll see a file referenced in a browser where it's file : / the path to the file, right? The idea is exactly the same. You're going to be able to do ik : / path to the file. And all of the tools that are built into Ikigai will not really care whether that is referencing whether a URI is for a file on the file system or a file in the database, right? So it lets us create database files. The idea behind pin and unpin is to pin a file is to add it to the agent's context. So if I had an agent that only had its message history and its system prompt, and I pin this file, doesn't matter if it's on the file system or in the database, pinning the file means that it's now part of the agent's context that gets sent to the LLM every time. You'll see that kind of incorporates into the other ideas here. External tools, most of the time, right? So the coding agent is going to offer tools on every request to the LLM. Currently, I am only offering 5 tools. They're pretty straightforward. They're the ones for reading and writing, editing files, looking at the file system, and one for running bash. That's actually kind of a fairly complete, you can do an awful lot with that. But the thing is those tools are built into the agent. And I am going to move them outside of the agent. They're actually just going to become executables that are sitting in a libexec folder where any executable file that's in there that responds to that supports the schema for input and output will just automatically be exposed as a tool to the agent. This is a system to make it user extendable. Again, one of the differences is if I make my tools work through this system, then end users can also extend the tools that are available to the agents. And those tools are just as efficient as built-in tools. Right now, the way that most people extend tools is the worst case is MCP because it tends to just bloat and use context. But otherwise, you do it through bash. You say, you're basically giving it an instruction to say, use bash to run this script. Well, if it does that, it has to spend the tokens to run bash, and it has to spend the tokens to kind of interpret the result that it was given. Whereas with this, it literally works as a tool. And so it sends JSON to the tool. It doesn't even know that it's external. And the tool will send the JSON back that the LLM expects. And so it's literally in its most efficient form. And realistically, you can provide an external tool by taking, for example, you could take the GitHub tool and wrap it in a little bash script just to the parts of it, let's say that for managing issues, because that's the only part that you want to consume context for in a particular agent. So you take the GitHub command line, you wrap it in a little bash script, you only expose the 5 or 6 methods it has for dealing with issues, and now you have this little compact GitHub issues tool that is just as efficient as if you had baked it into the baked it into the Ikigai originally, right? So that's that. I know for some people that's going to seem like splitting hairs, but everything I'm doing is to make it so you can control every last ounce, every single token that is sent to the LLM. Nothing is outside of your control. Okay, so moving on from there is internal tools. Calling these out separate, Cloud Code confuses these. You have slash commands. Some of them are internal built-in tools like slash clear. Clearly, what that's doing is it's triggering some internal code mechanism to clear the history, the message history. And then you have slash commands that the user can define. And what those are doing is reading a prompt template and taking the argument given to the command and instantiating the template with that, and then feeding that into context, right? And they're very different functions. Ikigai internal tools are slash commands, and they are only the trigger an internal function. And both the user can use them and the agents can use them. So an agent basically has a slash command tool. And what that allows it to do is to run any slash command that the user could have run. Whether that be, you never even shared it, but I will here in a sec, but whether that be clear, mark, recall, changing a model, anything the user can do is just a trigger of an internal slash command. Okay, now what Ikigai is going to do is it's going to distinctly separate those template instantiations, those things that people think are custom slash commands. And I haven't decided for sure, but the syntax will probably be bang command name, right? Bang command name arguments. They're going to be two completely distinct things. And realistically, that also will be something that the agents can do just as well, right? I'm realizing I didn't share something a little bit ago, but I'm going to do it now. What is 1 + 1? So I'm just going to put a little bit of history here into the chat. And then what I'm going to do is I'm going to say mark. I don't currently have a compact, although I could add it. Instead, what I tend to do is, because I want to control context perfectly myself, is I tend to use mark and rewind, where Claude Code has rewind to a conversation element. But I hate having to scroll up and go find the darn thing and click on it. So what I want is to be able to mark, and mark actually does accept a name. So I can mark with a name, mark foo, and then I can, here, let's put what is 3 + 0. So I just want to put a little extra history in there. But now if I ask it to rewind, you see what it does is it rewinds to the mark and no further. So it's like a clear to the mark, but no further. I probably should have shared that way back in the when we were talking about persistent memory. But to go a little further, skill sets. Skill sets, I'm going to show this with Claude Code because I don't have this implemented in Ikigai yet, and I've kind of faked it in Claude Code. So I have, Claude Code has a concept of skills, and I don't use them the way they have them laid out. The reason I don't use them is because Claude Code still preloads the name and description, 1 sentence or so description of every single skill. And so it's using, it just automatically uses that context, and there's no reason for that. So instead, what I have is in Claude Code, I can say, Claude, I can load, so I have a test-driven development skill, a TDD skill. And you could see that it went and found it in Claude library instead of Claude skills. And it loads the skill, and it works exactly the same as if the skill had been put in the skill tree and automatically loaded. I'm just not automatically loading it. Okay. Claude also, not Claude, but I have done this thing where I have skill sets. And so one of the ones that I use the most often is the meta skill set. The meta skill set is the one that knows about my project structure, what skills are available, how the makefile works. It's very meta, right? And I use it a lot. But you can see all it does is it went and the skill set is defined to preload a bunch of specific skills. Okay, so Ikigai is going to have that as a built-in concept. I'll talk about it a little bit more because the very next thing is tool sets. Tool sets are exactly the same thing. Ikigai might spin up and it might read all the tools that are in its tools directory. And let's say there are 40 of them in there. I don't actually want to give the agent that's going to summarize some text all 40 of those tools. So what we'll do is we'll have a tool set that you can define that you give to an agent. So basically load this tool set. And then from that point forward, it only has the tools it needs. The skill set, load these skills. It's the only skills you need, and you get to name them and do them in one pop. You can also load them individually. All of those things are going to be available. Moving ahead a little bit further, I have this wrote in here now as modes. The idea was that I could do a Claude Code mode, but I think that the name needs to change. The idea being I can make Ikigai look and act exactly like Claude Code by combining a system prompt, skill sets, and tool sets all together and saving it as a mode. And then I could have the Claude mode, and I switch to Claude mode, and it should be able to work in a project that is 100%, dedicated to Cloud Code, and you shouldn't notice the difference, right? That's the eventual goal there. I think the name is a little confusing, and it probably will change in the future. Structured context. When all of this first started, you basically had, and you can kind of tell by the evolution of the APIs, when this first started, you had the message history, and that is basically a user prompt and a model response. And then the APIs, at least as far as I'm aware, Anthropic added system prompts to the API. And so you could send the system prompt separate from the message history. I think prior to that, I'm assuming that everybody was just baking the system prompt in as part of like message zero, right? And so now you get the system prompt, the message history. Well, truth is when you're engineering the total context, you start to think of all of the pieces individually. And so the way I see it right now is there's the system prompt, user pinned files, the skill set, the tool set. These are all things that have to be put into the context. A historical summary, which I'll get to in a second, and then the message history. At the very top of the message history, of course, is going to be the most recent user request. In truth, under the hood, system prompts, skill sets, and are probably just pinned files, or they're using the same mechanism as pinned files. The tool sets will be probably a little different because they have to generate the schema for arguments and stuff that the LLMs expect. The idea, though, basically is that all of these pieces exist, and the message history is just one of them. And one of the things that you'll be able to do with Ikigai is, let's say you have a skill pin, you have a skill set tool, you have a skill in a tool, you have a skill in a skill set. If you go and edit it in real time while you're in the middle of a conversation, and then you send the next message, the next prompt is going to see that change. So you can kind of simulate this in Cloud Code. The way you do it is you build up your context. You clear, and then you add just the things that you want into the context, and then you do your actual work, and then you probably rewind to where you had prepped things, and then you just keep rewinding to where you had prepped things, and that's kind of your ability to pin exactly what you want in memory for that work. Bunch of problems with that. You have to methodically go, put all the pieces there. B, if you want to change something that is in those pin files, if you want to change the skill set, for example, you have to clear again and rebuild it. So that will be a difference with Ikigai. It's all about, like the surgical precision of managing context. Okay. This is truly an experiment. I don't know if it'll be how I do things in the end, but the way I'm seeing it right now is message history is just the space that's left over after all the pinned documents and the tool sets, et cetera, et cetera. That's your maximum message history space. My thought right now is that it's just a sliding window that's moving through the message history, and crap is falling out the backside of it, and you are forgetting those. But if we go back to this previous slide, I had historical summary as one of those blocks. And if you dedicate a little bit of space, a few thousand tokens to historical summary, that works really well to, I'm hoping, it's basically RAG. You are putting a little bit of history in there, and then you classify it. You have a chunk of history that's a little bit more verbose, and it's describing what happened in the previous session, right? The stuff that's fallen out the back of the message history. And then maybe you have some more that describes the previous few days, and you might even have a couple of lines in there that say, hey, these are the things that we did last week. And then you combine those with tools for recalling memories from that permanent history. So we're all the way back to the very, very beginning of where we started talking. The permanent history has, it goes all the way back to the beginning of time. And so if the history summary references things in a way that the recall command can then pull them back into the current context. That's the idea there. The idea behind the forget command is it's more surgical than compact. So like in Cloud Code, you compact. But what that does is it just says, hey, reduce this, blob by 50% and try to preserve as much context as you can. But it doesn't really know what you're going to need in the future. But you do know what you need in the future. And so the idea behind the forget command is it would work something like this. You're working along interactively, and let's say you're trying to do a feature, but you get a little bit sidetracked for a couple of turns where you squash a bug that you run into. Well, the idea behind the forget command is that you can tell it to just selectively forget all conversations about X, and it will take an external agent, and it will just read through that message history and just kick it out of the in-memory representation. It'll hide it, and so that is no longer taking up memory that or context history with the LLM. We're starting to get into the pretty speculative areas, but these are the things that were originally driving me, the goals that I wanted to do, and things are starting to move pretty fast, and they're not that far away. Now, I don't have a slide for it, but if I go back up, I mentioned here external agents. Ikigai, I'm not going to talk a lot about this, but Ikigai is going to offer up an API, and you're going to be able to run an external piece of code, Python. Probably, actually, I'm only going to bother initially to support TypeScript because it'll have a API. Anything could connect to that. I will do the libraries for the TypeScript version. But external agents, they're operating completely outside of Ikigai. Will be able to run agents with all the facilities of an Ikigai agent that's running internally. It'll provide an API that allows it to do it, except for essentially that the external loop is going to be code. You can't currently do this with Cloud Code. You have to do what Cloud Code offers you, and I'll offer this piece too. Cloud Code has you can do Claude-P and pass it a prompt, right? And it runs as a headless agent and spits out an answer. And what people have done is they kind of cheat. They have inside of Cloud Code, they'll have it use the bash tool to run a script that's on the outside that runs a headless Claude. It's really kludgy. And the whole point of what I'm going to do with external agents is that you'll be able to you'll just be able to write some TypeScript. It'll pull in a package. It'll be able to connect to and create and interact with all of the Ikigai features as if it was internal. And probably also you'll be able to run it you'll be able to run Ikigai headless, and so it could become a deploy target if that's what you want. Anyway, that is the introduction to Ikigai, and I'm sure it was way too long, but that's it. Thank you.